Hello everybody and welcome back. Today I would like to talk about the G43 and K43 gas operated semi-automatic recycling system. The whole gas system is hidden underneath the upper handguard, and in order to get to it we have to remove the handguard. For that we have to press down here on the right side on this little tang. We have to press it in and carefully take off the nose cap. And once the nose cap is off, we can slide the handguard forward and it exposes the gas assembly. What we see here is the operating rod with a spring, the connecting rod, the gas cylinder. Inside the gas cylinder is the gas piston. Let me pull this back. So this silver part, it's stainless steel, that's the gas piston. And the gas piston is screwed into the gas block. The gas block has a hole connecting the gas piston to the barrel, and once you fire a round, there is pressure building up behind the bullet as it travels through the barrel, and once it passes the gas block, the gas pressure that has built up behind the bullet will move the gas cylinder backward. And it will look just like this. So it removes it backwards. At the same time as it does this, it pushes the bolt carrier to the back. Let me show that again. You see how it moves the bolt carrier back. Now, I also would like to focus attention on the fact that it doesn't move the bolt carrier all the way back. This is pretty much the distance the gas cylinder can travel. Now look at this. As I'm bringing it all the way back, the bolt carrier is not even close to clearing the magazine. Let me show that. It needs to go back as far as right here to clear the cartridge, pick up the cartridge and push it forward into the chamber. Now again, watch the rod. There's ample space between the face of the rod and the face of the bolt carrier. Now how does the system work if there's so much missing? The word is inertia, and this is similar to kicking a soccer ball across a field. The harder you hit it, the farther it will fly. And that's the same here with the gas system. The gas pressure developing in the gas cylinder will rapidly move the rod towards the bolt carrier. The rod will hit the bolt carrier and just propel it back. And inside the bolt carrier, or inside the bolt assembly to be exact, is this recoil spring assembly. And these springs here, the operating rod spring and the recoil springs, and the gas energy in the gas cylinder, all together they make for the appropriate travel of the bolt carrier. Now originally the G43 and K43 gas system has been completely over-designed. In this day and age where we shoot the rifle on a range, everything is running smoothly, there's no obstruction, there's no dirt, no grime. This rifle was mostly built for the Eastern Front, for operation under cold temperatures, exposure to dirt, snow, and it had to operate reliably under all these circumstances. So what the engineers in the Walter factory did is they over-designed the gas system so it would reliably kick the bolt carrier back to the very end where it could actually allow for rechambering a new round. Unfortunately, in this day and age, as we are operating these rifles, there is not enough friction to stop this bolt carrier on its way back, so it will hit the back end of the bolt housing and of the receiver very hard. And over time it will fatigue the material and the back end of the bolt housing will crack, and in some cases the back end of the receiver will buckle, and that's a very costly repair and nobody wants to go through that, but it's doable. So the trick is to install what's called a shooter kit, which is a gas piston that has a reduced orifice that only allows a certain amount of gas energy to propel the cylinder back, and in that case it will not damage the rifle as it would be without the restrictor in here. It's also very important to shim the whole gas system carefully, and the issue is, as the bolt is closed, there has to be a certain amount of play within this assembly, but not too much. And if you look at the gas piston, so what I will do right now is I just position my thumb right behind the bolt carrier and I move the gas piston, and this is how much play there is in this system. And as you can see, I'm positioning my thumb behind the bolt carrier and I press it firmly against the receiver. This is a situation when the bolt is just closing, it slams against the receiver, but then it also bounces back just a little bit. So this is the extreme position when it slams, and when it bounces back, or after it bounced back, it rests in what I call the relaxed position, and that is the position the bolt carrier is in once you start pulling the trigger. Now, in that position, in the relaxed position, there's even more slack in the system. And we have to determine how much slack there is, and we have to reduce it to a smaller amount. So let me take a caliper and measure. So let's hold this for a second and get the caliper. Just slipped. Let's do that again. There we go. A little bit hard with. And we have about 60 thousandths of an inch play. Now ideally we want to have about 30 thousandths. More than that, and the operating rod will slam very hard on the bolt face, or on the bolt carrier face, and there's the chance that it may crack from the impact. So we want to reduce the slack in the system. Now let's take the system apart and see where we can insert some shims to make it work properly. First we have to pull the operating rod all the way back and remove the connecting rod. It's hard to see, my hand is in the way now, I'm sorry. And then remove the gas cylinder. And this is the gas piston here. So now we can take out the operating rod. One thing we have to look at is the area down here, the hole where the operating rod hits the receiver when it's all the way in. On systems that have not been modified with a gas restrictor, it will impact very hard and it will mushroom the little rim around the hole to a point where the rim starts catching on the spring, and then the spring cannot move freely. So this needs to be filed if there's any kind of a mushrooming visible, you have to carefully file it, take that off and flush it from this side with WD-40 to get the debris out. So now in this case, we know we have 60 thousandths play and we want to reduce it to about 30. So I do that using a washer. Now this washer is about 40 thousandths thick. That's just borderline. I like to have it about 30 thousandths, so starting from 60 thousandths and having a washer of 40 gets us to 20. So 20 is probably just about right. And we will put this back together. Now this washer will go between the gas piston and the operating rod. And this will take the slack out of the system. So in order to do that, we have to first push the operating rod in and install the gas piston. Now install the connecting rod and watch your fingers here. There we go. As you can see, the play has been significantly reduced. And this is about what you need. This is enough play for the system to operate even if parts expand or contract during shooting due to hot temperatures of the barrel. But this is pretty much the optimum you want to have. And this will guarantee that your operating rod impacts the face of the bolt carrier with very mild impact force, and the bolt carrier will not crack. So when this is done, you can basically put it back together and you install the upper hand guard, install the nose cap, insert the magazine, and you're ready to go. Now it's recommended to clean the gas system every time you come back from the range because there's usually some carbon buildup and you want to take that apart, clean it very nicely, give it a thin layer of oil to keep corrosion out, and just make sure, every couple times when you come back from the range, just take your caliper and measure and make sure that you still have the proper spacing and your rifle is in a good operational condition. So that's it for today. Next time we will talk about installing a shooter's kit and adjust the shooter's kit so the rifle will see the absolute minimum of wear and tear during recoil. Thank you so much and happy shooting!